Hello everyone. I wanted to make this video to go through the instructions for Project 1 because they're a little bit wordy, and so this gives me an opportunity to explain what I mean. In this project, we're going to be implementing two different machine learning algorithms in C++, and we'll compare the results and the performance to using equivalent pre-built functions in R. So you'll be writing two R scripts, two C++ programs. There'll also be a report, and you'll upload that by zipping it all together. Specifically, you're going to do logistic regression in R and also do some graphs and data exploration and metrics. And then you're going to implement that algorithm from scratch in C++. And you'll do a similar thing with naive Bayes. And then you're going to make a report. I don't care about the format of the report in terms of font or anything like that, but I anticipate you'll need about 3 or more pages. And then for each algorithm, I want you to compare and contrast R and C++ in terms of run times. And we'll talk a little bit more about how to do that later. I also want you to include screenshots of your timing runs and screenshots of the graphs that you build in R. This is an individual project, and it's going to be graded by a peer review process, which I'll describe later in the video. In this course, we're going to be using a lot of pre-built R and later Python functions for machine learning. I have you write a couple of algorithms in this project in C++ for two reasons. One is that it gets you thinking about how these algorithms really work. You understand these two algorithms much better after coding them up than just running them. And my second reason is that if you pursue ML further, there may be times that an off-the-shelf solution doesn't do exactly what you need, and you may have to code up something original. The language that people use for that is C++ because of its speed. A third reason I'll give for having you code these up in C++ is the bragging rights. It just sounds pretty cool to say that you coded up your own machine learning algorithms in C++. Part of your report is to compare the runtimes for R versus C++. So let's talk about how you can do that. One way you can do that in R is to use sys.time. So let me pull up a sample here. This is a linear regression script where I've divided train and test just by index number. And I've set up start time to be like a timestamp here. Then I do the training and then do an end time. And then at the very end, I calculate run time as end time minus start time. And it was 0.001 second. It's important that you just time the training. Don't time anything else in the script. All right, what about C++? You could use Chrono, as I show here. Let me show it in the context of a program. This program is where I coded up linear regression from scratch. And here I'm including Chrono. Then down in my main program, after I read in the data, I'm going to let start be a timestamp. I need to calculate these means. But these two functions are where I'm actually doing the training. And then I have a stop timestamp, and then these two lines of code output the duration, which was right here, 0.00006 seconds. So much faster than R. Let's look at the rest of the instructions, the more detailed instructions. First, logistic regression. We're going to use the Titanic project dataset. You'll use the first 900 observations for training and the rest for test. In logistic regression, we're just going to model survived as a function of passenger class. So you'll do these steps in your R script, and then you'll implement it in C++. There's going to be some matrix multiplication involved, which I just kind of grinded it out using indices. You may want to check out the Armadillo library for matrix multiplication. And feel free to use whatever programming paradigm you like. You can do it object-oriented if you want, but I'm always suspicious that that object-oriented nature of it may slow down the results, but maybe not. So what do I mean by from scratch? I have a reference here in the book of this section, which looks at R, how you could do logistic regression from scratch in R. And so this could serve as your pseudocode for doing it in C++. So we have a function here to count for the sigmoid function. I set up some weights. In R, I have to set up a data matrix. The purpose of this was on an ESR data set where the coding was 1 and 2 instead of 0 and 1, so that's the reason there. And here is just an iteration of optimization. Calculate using the sigmoid of the data matrix multiplied by the weights. So this notation in R means do matrix multiplication. And that gives us our probability vectors. Since we started off with our weights being 1 and 1, this is going to be way off. We calculate exactly how off it is. We update those weights. We take our weights plus our learning rate times the transpose of our data matrix times the error to figure out better weights. And we do this for many iterations. Here in this table I showed that for different numbers of iterations, the more iterations, the more accurate these weights, WZ being the intercept, W1 being the weight for the predictor. So this 50,000 iterations in R was probably good enough. What that will be in C++, numbers of iterations in C++ to see when you get to a point where it's accurate enough. In other words, comparable to what the R program told you. All right, and then of course you'll write your summary with screenshots of the output and the runtimes, and also include screenshots for the graphs that you're going to create in the R script. And just to be clear, I would want you in the C++ program to output the same metrics that you used in your R script. All right, you're going to do a similar thing for naive Bayes on the same data, except now we're going to model survived as a function of passenger class and age and sex. And again, for the C++ program, I have some reference in the book that should help. I also have a video link when you get to the age predictor. It's a little bit trickier. Here's a formula for it, and this video kind of explains this a little bit better than just looking at the formula. This section of the book, 710, gives you a rundown of naive Bayes from scratch in R, which again will be your pseudocode. Here we have output the probability tables from R, and we want to make sure that our C++ code gives us the same probabilities. A lot of what we'll be doing is just counting and dividing. For example, for the prior is just the number that didn't survive divided by the total number, and we store that in a table. For our discrete predictors, again, we're just counting. To kind of facilitate that, I have a data structure that holds the counts of survived. And then for each passenger class or for each sex, we'll go through and calculate our likelihood. For example, the count of people in passenger class 1 who survived divided by the total number that survived. So that's pretty straightforward. For our continuous variable of age, we need to calculate the mean and variance first, and we'll store those. And then this function will implement that formula for the likelihood of a continuous variable. Then we have to put that all together. Since this is rather unwieldy to multiply all these things, I separated out a numerator for survived, the likelihood given the class, and the likelihood of the sex times the a priori times the likelihood of the age. Similar thing for if they perished. And then the denominator is this big thing right here. So we're calculating the probability that they survived is that numerator we calculated divided by the denominator. and then a similar thing for the probability that they perished. And I show that for the first 5, I got similar results. So in these projects, R is serving as our ground truth for what is correct. If you're getting the idea that this is not an assignment you should put off till the day before, you're absolutely right. All right, the next part is report. For each algorithm, I want a summary of the 2 implementations. First of all, did you get the same result between R and C++? How do the times compare? And then let us know how you measured execution time. I want screenshots of the output as well as the runtimes. And you'll also have screenshots of the graphs you made in R. I don't require any specific format for the report. When you get ready to turn in your project, around that same time, I'll come up with a spreadsheet that randomizes your net IDs. Each person will send their project to their 3 reviewers so that each person in turn should get 3 random projects to grade. And you'll grade it according to the rubric that was at the top of this document and repeated below. Deduct points if they didn't follow the directions. And you will get a 100-point homework grade for doing a good job on this review. So you can copy and paste this into a Word document, and you'll have to give yourself more room. I want your name, your net ID. So notice that you need to grade each component, make sure they did all of these things, and then you can give them a total grade here. And then you'll have to give yourself a lot more room to write a couple of sentences for each component, justifying why you gave the grade that you did. Don't forget to put the project author's net ID here. And by the way, if you don't get 3 projects to review, that won't count against you. So how is your project grade determined from these peer reviews? What I do is I make a big spreadsheet and I average the 3 peer reviews for your project grade. What happens is that some people tend to grade very loosely and some people tend to grade very strictly. With 3 reviews, I've found in the past that averages out. And I've found a very high correlation between the average of 3 reviews and what I would have given the project had I not seen those 3 reviews. The final determination of the grade is up to me or the TA, because we'll look at your project independently and see if that average grade is reasonable. And this is why the comments are very helpful to us when we grade these projects. Right, so we'll revisit this if necessary when we get time to the peer review process. For now, you have plenty to get you started on coding this up. Again, the project part itself is worth 250 points. You get 100 points, which should be an easy grade for doing the peer reviews, provided that you do a good job. I'm sure we'll have more discussion of this on Piazza. Happy coding!